This is the assignment that goes, or the lecture that goes with your assignment number 10. We're going to talk about topic 7.1, factoring by GCF and grouping. So remember in some of those previous lectures here in Unit 3, we talk about inverse of things often. So before, you were given something that looked like this and you distributed, which means you were multiplying 5x times 2x gave you 10x squared, and 5x times 3 gives you 15x. Well, we're going to do the reverse operation. We're going to factor, meaning we're putting parentheses back into the problem. So if you're given this, you need to ask yourself what can go into 10 and 15, which I know 5 can. And then we look to see variable wise, what do they both have? They both have at least x. So the variable part will always be the smallest power, assuming they both have it. If they both don't have a variable, then you can't take a variable out. So when we pull that out, to figure out what goes on the inside of the parentheses, we divide. So just like here, we were multiplying to remove. The inverse of that is divide. So we would divide by the 5x. And so 10 divided by 5 is 2, x squared over x leaves you with x. 15 divided by 5 is 3, x and x zero out. So that's what we're going to be learning. Before we actually jump into doing that though, we're going to just practice finding a GCF between some terms. So let's look at example 34. Just kind of underlying the terms just to draw attention to them. 10 and 15 can both be divided by 5. They both have x's and y's, so we can take an x and a y out. The smallest x is x, so we would just pull out x, and the smallest y is y squared, so we pull it out. So we could only take out a 5xy squared. So what this means is if you were to divide by 5xy squared, it would divide up into that, okay? We couldn't take, like, for instance, x to the third, the bigger exponent, because this term only has one x while this one has 3. So they need to both have, you need to take the smallest because they both do have at least one x within there. 35, we're looking at 3 separate terms, 6, 9, and 12. So while 6 can go into 9, it can't go into 12. We can't take 6, okay? Just kind of want to draw attention to that. The only number that can go into 6, 9, and 12 is the number 3. And then variable wise, we have x's and y's on all 3 terms. So we're just going to look for the smallest exponent. So we have a 4, 3, and 2. So I'd take x squared. And for y, we have a 2, 2, and 4. So we'll just take 2. So that's just practicing finding a GCF between some terms. There's not a plus or minus sign, so we weren't actually factoring, but we were finding what the greatest common factor would be. Now we're going to practice finding a GCF of terms. This is always the very first thing you do in any factoring problem. This assignment focuses only on that though. So just remember that as you're learning how to factor further after this topic, you'll be doing it a lot. Okay, so let's look at these 2 terms. I like to underline them just to draw attention to them. 14 and 7 can both be divided by 7. They both have x's and y's. The smallest x is x and the smallest y is y. So my GCF is a 7xy. So we pull that out in front. Then we go divide to see what goes on the inside of that parentheses. So we know 7 goes into 14 2 whole times. For x, you're taking 2 minus 1 to get x to the understood 1. For y, 3 minus 1, and you have y squared. Minus 7 goes into 7 1 whole time. Your x is 0 out and your y 0 out. Notice I put lines through them. I kind of like to think of those more like the number 1. It's not, I want you to be careful if this ever happens. If you take a term and divide it by itself, remember it can divide up into be one whole. So it's not that that goes away. Sometimes students will, kind of like think that it cancels out and it's like disappears. It doesn't. You need to put the number 1. 7xy divides up into itself one whole time, just like if it were 7 over 7, right? 7 goes into into itself one whole time. So remember again, talking about that, this is the opposite of the distributive property. So if you wanted to go check yourself, what would you do? You would just multiply to show 7 times 2 is 14. Add those exponents. 1 and 1 make 2. 1 and 2 make 3. 7xy times 1 would give you that negative 7xy. Let's come over here. We have these three terms. So we get to practice one more of these. 6, 4, and 8 can all be divided by the number 2, and they all have a's and b's. So the smallest a I see is a squared, smaller than 3 and 5, and the smallest b I see is b, 3 and 4. So I'm going to pull a 2a squared b out from these terms. So we will be dividing to figure out what goes on the inside of a parentheses. So 6 divided by 2 is 3, and subtract your exponents. 5 minus 2 is 3, so a cubed. 4 minus an understood 1 would give us a b cubed. Minus 2 goes into 4 2 whole times. 3 minus 2 is a to the understood 1. For b, 3 minus 1 is b squared. Plus 2 goes into 8 4 whole times. A squared's 0 out, and b squared, or b's 0 out, so we can close out parentheses. So again, in factoring, the whole purpose is to put parentheses back into the problem. It's kind of like you're pulling out what they have in common, setting them out in front, and then leaving what would be left over after you divide in the parentheses. When we move on to the second part of this assignment, you learn how to factor by grouping. You do a lot of factoring by GCF. So you have to be able to find a GCF to be able to do the next method. Factoring by grouping is just, you look at this, generally you start with 4 terms. I know this one isn't 4 terms. This is kind of like in a second step. This example 38 is, but generally you start with 4 terms. And if you look at that, not all 4 of those have the same thing in common. These 3 have X's. This one doesn't. A couple of these 2 things could be divided by 5, or these 2 things could be divided by 2. So they don't all 4 have something in common. So that's how we would know if we weren't told how to factor. That's how we would know that it's the grouping method. So what we want to do is group the terms so that each term has a common factor. So I'm going to go straight to example 39 to show you that, to go through these steps, and then we'll come back to 38. So I underline them in 2 different colors to show the 2 different groups. I'm saying these 2 things have something in common. And they had x squared in common, at least, x's, but the smallest was x squared. So I can pull out an x squared. So when I do that, I divide by the x squared. So x to the third over x squared is x, plus the x squareds here would 0 out, you would have 2. Okay, and then we're going to look at the next one, 5 and 10. They both can be divided by a negative 5. Sometimes you may pull out a positive, and we'll talk a little bit about that in another example. I knew I wanted to divide with a negative though, because a negative divided by a negative would make this a positive x, and I need it to be a positive x, because what's happening is I want to get matching parentheses so that we can factor that out. I'll talk about that when we get to that step. So negative 10 divided by negative 10 is a positive 2. Okay, so what we've done is we've grouped it and we've factored them out. And again, kind of restating what I just said, after this first step, what we want to happen is for these parentheses to match exactly. If signs are off, you may need to do something different with your signs, but they need to match exactly. And so since they do, we just say that that is a common factor. So we get to write it out once. And in our second parentheses, or what's in front of those parentheses, we create a second parentheses, so x squared minus 5. And so that would be our answer. So I just want to say, like, if you were to go back and check this, for instance, you would have to distribute. We talked about the FOIL method in previous lecture. You could pull these apart. It's just that it would be pulled apart kind of backwards. You could distribute your x squared this way if you wanted, and it would be getting distributed to the x plus 2. And you could distribute your negative 5 to the x plus 2, and it would be getting distributed to the same x plus 2. So that's why we just write the x plus 2 down once, because this would be like it's expanded. So we write it down once, and what's in front of the 2 parentheses, we put them back together. So if you ever see a problem like number 38, that's kind of already in the second step where we can factor out this like factor. It's not just a term that's a like factor, it's actually a binomial, but that's okay. It's a like. So we have 2x plus 3. And in our other parentheses, we put 4x squared minus 7y squared. So if it's ever in this spot and those parentheses already match, then you really don't have to do anything. You just simply put them in a parentheses and you're done. It's that easy. If you turn the page, you'll notice in example 40, it's kind of a weird grouping. Maybe that would work, but sometimes you may need to rewrite the problem. And one thing I would recommend is always rewrite it in descending order. Notice this is not in descending order. So you may have to be forced to rearrange your problem. Not always, but sometimes. And so I'm just going to rewrite it to put this in descending order, practicing that skill we learned at the beginning of this unit. So 2x cubed, that's a negative 8x squared, a negative 3x, and a positive 12. And so if I group it like that, or if I rewrite it like that before I group, it's going to help us with our grouping method. If you try to do it these first terms and the last two terms, you're probably not going to get like parentheses just because of those variables. Like these two wouldn't have x's in common, so you couldn't have pulled out an x. Well, nothing's going to have an x cubed over here. So anyways, these two terms that are underlined in black in this first group have the number 2 in common, and they both have at least x squared. So we're going to factor out a 2x squared. After you do that, then you'll do that dividing. 2x cubed over 2x squared leaves you with x inside that parentheses, minus 2 goes into 8, 4 times x squared and x squared 0 out. So we have just simply done a factor by GCF problem in that first group. Going to our second group, we could look at that. I want you to remember that there's a minus in front of that 3x. But let's say we just noticed that maybe they could be divided by 3. Let's say we say, I want to divide by a positive 3. Make sure you always connect this with a plus or a minus sign. If it's a positive 3 that you're dividing by, you need to put a plus sign there. If it's a negative, you would put a negative. I drew attention to that because if I say negative 3 divided by 3, that would be a negative 1x. And then if I say 12 divided by 3, that gives me a positive 4. So it looks kind of good. You know, we notice we have x's and 4s inside the parentheses, but what we do notice is both of them are opposite of what they need to be. Like this is a positive x, this is a negative x. This is a negative 4, this is a positive 4. So it really doesn't match. So what we should have done is divided with a negative. Okay, so let's kind of scribble that out and say, what if I would have divided by a negative 3 instead of a positive 3? Well, negative divided by negative would have made that a positive, and a positive divided by negative would have made that a negative sign in between them. So if we were to have divided by negative 3 and not just a positive 3, we could have got the right signs. They could both be positive x's and negative 4 or minus 4 between. Now we have matching parentheses. So we have x minus 4 in a parentheses and 2x squared minus 3 in the other parentheses. Looking at example 41, it kind of shows a little bit of what we just talked about in 40. First of all, notice that's in actually that second step, right? There's already some parentheses in that problem, 2 different parentheses, and it's being separated by a plus sign right there. The only thing is, number 1, this is written opposite of what the other is, and they both have a minus sign. While that seems like they match, they really don't, because if you put this in correct order, that's really a negative x and a positive 7, right? So let's think of it like that. So when we notice that, again, yeah, they both have x's and 7s, but they have the opposite sign of what we need. So just like what we did in example 40, we could fix that. We could say, well, since this is a positive 4, if I change that to a negative 4, it's kind of like you're multiplying that times a negative to manipulate the signs or dividing by a negative. And so that would mean that you're making this a positive and it's a negative. So sometimes you would just go change those signs. Now, this might have made more sense because you could actually see the pulling that GCF out from the numbers. And that if I would have divided by a negative, it would have made it what we needed, a positive and a negative. But this was already in our second step. So if you ever need to manipulate the signs, you just need to know that you'll change the sign of the number out in front, which changes the sign in the middle. And what that means is it was like you pulled out a negative in your factoring. Now that we have matching parentheses, x minus 7, we can write that down. And in our other parentheses, we have 5x minus 4. So factoring by grouping is honestly not a type of factoring we do a whole lot of. When we move on to your next video to topic 7.2, we do a lot of this, but it is important to understand that because I think that's the type of factoring that students kind of brush aside and don't remember how to do. So I highly recommend you rewriting these 4 problems on your own, do them again. Practice the factoring by grouping method. You'll have some on your homework. Do those a few times to practice that method. That way you don't dismiss it, since we don't see that method a whole lot. You do see factoring by GCF a lot, and I know I only gave 2 examples of that. If that's all you had to do, it would simply just tell you factor by grouping. Okay, so you're gonna, or I'm sorry, factor by your greatest common factor. So you're gonna be told that that's really all you're doing in this first assignment. Factoring by grouping method, you'll be told to do that, but also you'll notice there's 4 terms. And so you'll know that this is the method that you're gonna need to use from your notes. So have them out, look at them, practice the ones that we've done together before you do the ones in the homework. If you have any questions, please let me know.